Welcome, everyone. This session is called Best Practices for Orchestrating Your AWS Lambda Workloads. And hopefully, you actually read the abstract and you saw that I'm going to be talking a lot about Lambda, and I'm going to be talking about step functions. Now, I did a talk last year about Lambda, and it was really popular. A lot of people were there, and really pretty exciting. And it was, the new hotness. And I feel that there were some things that Lambda couldn't do. I don't want to say that. That would annoy Amazon. But there were some things that were a little harder to do with Lambda. And now we can do them, thankfully, with step functions. And I'm really, really excited about them. So I'm going to get right into it and talk about step functions. Are you ready? Here we go. OK, so about 8 weeks ago, 2 months ago, my wife and we took a vacation. It was amazing. Here we are up on a bridge looking back at the Ponte Vecchio in Florence. We're over the Arno River. I was staying with some friends at a friend's apartment, and it was just amazing. The weather was perfect. It's so wonderful. I'm a big fan of Wistia, but that's irrelevant because the selfie is totally relevant. And after Florence, we drove on out to Tuscany, and we stayed at this lovely agriturismo in a little town called Cedri, or something like that, near a slightly less small town called Peccioli. Now, if you look in the guidebooks, these areas are not in the guidebooks, so there were no tourists, and it was amazing. It was so peaceful. It was so lovely. And in fact, I've been doing a lot of traveling over the years. I got a lot of stamps in my passport. I've been to a lot of countries. But this trip, you look at all the trips I've been on, this trip to Italy with my wife was different. Because I made a promise to my wife. I said, okay, sure. When you make a promise to your wife, like a few months before, it's like, no problem. Yeah, sure, I can do that. I'm going to leave my laptop at home. Yeah, I can do that, no problem. That's going to be easy. Leave my laptop at home. I'm going to enjoy the vacation. I'm going to focus on you. It's going to be wonderful. I'm not going to be hunched over the laptop. Not that I would ever do that on vacation. Because I've had a laptop for a long time. I had my first laptop in I went to college in 1988. I went up to Florida State University with my Toshiba T1000 8088 powered processor. Oh, it was amazing. And ever since then, pretty much every trip I've gone on, I've had a laptop. But this time, I'm going to be different. No laptop. OK, no big deal. Who needs a laptop when they're enjoying Tuscany? Well, it became a bit of a problem because a little bit of a technology decision I had made somewhat recently. Updating my blog has been, on my New Year's resolutions list. My New Year's resolution this year is going to be to update my blog more often. This year, and last year, and the year before, and the year before that, and the year before. And it's like for the last 15 years, I've had this goal of updating my blog more often. And you can see here's my blog right now. The last post was November 1st, and within like 5 posts, we're back in 2015. Obviously, I'm not doing very good on my New Year's resolution. So I mentioned that I made a technology change. So I used to run my blog on WordPress, on a DigitalOcean droplet. But I decided for some reason that I wanted to migrate to Hugo. At the time, I was using Surge. And then later, I moved to Gatsby.js and hosting it on S3. Now, Hugo and Gatsby are pretty amazing tools. At the moment, I'm really enjoying working with Gatsby because they're static site generators. Now, with WordPress, you work on your development machine, you make some tweaks to your website, you push that up to your server, whether it's some Colo or on an EC2 or maybe WP Engine or something like that. A user comes to view your website, they make a request, and it processes for a little while, maybe not that quick. Maybe it's that quick, I don't know. In my server, it wasn't that quick. So it processes for a while and and returns an answer. With a static site generator, I'm still going to be working on my site locally, but when I do a compile stage, so my computer works kind of hard, converting my Markdown files to static HTML and JavaScript, and pushes it up to the server. And then when a user comes in, makes a request, and they get their answer super quick. It's like blazing fast, and goodbye. Pretty much, you've got a minimal security footprint. It's really great. Now, I mentioned that this was a bit of a problem because I'm without a laptop. And I did have my iPad, but at the moment, there are no static site generators for my iPad. At least I can't figure out how to get that to work. So this is a bit of a problem. Now, I could buy or pay for an EC2 instance and put all the logic up there and run that remotely. But now, well, you've seen how often I update my blog. Now I'm paying for an EC2 instance for 5 minutes every 3 years. That's not really that useful. So serverless seemed like the perfect solution for me. And in fact, I was wondering, okay, what is the demo I'm going to show at reInvent 2 months ago? And then I thought, this is my demo. This is my demo. Oh my God, it's going to be amazing, hopefully. So here's my demo. Here, I'm going to be talking about step functions in the context of 2 step functions that are building my site. And they are building it live. In fact, I am live blogging this session right now. If you go to that website, sf.technoevangelist.com, you are going to see a live view of this website. Now, how am I doing this? Well, if you notice, way over here on this side, there's one of the seats is empty. Okay, there's a couple other seats that are empty. But there's one seat that's empty that's got my little tripod on it and a Raspberry Pi. And my Raspberry Pi is taking photos every 30 seconds of that slide area. And every 30 seconds, it's uploading that via API gateway to S3. And then it's handing it off to a service called Vise.ai. And Vise.ai, I've already uploaded 6,000 images of all my slides in different orientations with different backgrounds so that it does its whole machine learning magic stuff on it. And so now it's able to recognize which slide I'm on automatically. And then it lets Lambda know about that. And the next Lambda goes and grabs my notes from a DynamoDB, pulls that back in, creates a Markdown file in S3, triggers off a build in code build to pull my latest Gatsby.js site out of code commit into code build, does the build, pushes that out to S3, and I'm doing that all live as we're talking. And it looks like it's kind of working. Sweet. Okay, so my name is Matt Williams. I'm an evangelist at Datadog, and you can reach me on Twitter at technoevangelist, or you can send me an email at mattw@datadog.com, datadoghq.com, sorry. Anybody in here in the room from Boston? Okay. Did any of you attend DevOps Days Boston? Okay, cool. Then you have seen me before because I was up on stage there introducing you all to what we were going to be doing because I was one of the organizers of that. We're looking forward to next year. It's going to be awesome. Hopefully you're going to attend that as well. I work for a great company called Datadog. Hopefully you know about Datadog. How many of you know who Datadog is? Yes. Probably because you've seen the amazing booth in the Venetian or the pretty amazing booth here in the ARIA as well. So we're a SaaS-based monitoring and analytics firm. We do infrastructure monitoring, so we're collecting all of your metrics about all of your stuff. And we do APM, and we do logs. And we have this open source agent, and we're collecting trillions of data points every day from all of our customers. If you haven't had a chance to visit our booths, it's totally worth going to booth 109 in the ARIA, pretty much as soon as you walk in. And then booth 1021 in the Venetian. And it's the really huge one with like what is it? A hexagon, yeah, of video displays hanging above the. It's just gorgeous. It brings tears to my eyes. Anyway, we are hiring, so if you're looking for a job, we are totally hiring, and we're the better place to go. Okay, cool. let's move on. So last year, I mentioned that I talked about Lambda, and this was actually the room I talked in. It was really cool. It was built for Phantom of the Opera. Oh my God, it was beautiful. I talked about Lambda, and it was really a great session. And yeah, this is the photo I mentioned before. If you look really closely, it looks like everyone's asleep. This was before the session started. They weren't really asleep for my talk. It was awesome. Now, in that talk, I showed something like this. So I talked about the migration from physical boxes to virtual machines, onto AWS instances, onto containers, and onto Lambda, mentioning Lambda as this potential holy grail. It's going to be amazing. There were some things I said that, looking back, probably not the they're not exactly the best practices, because you look at this. Well, let me go over some of the basics. AWS Lambda, one of the problems here is it's not the same as EC2. You look at that diagram, that super simple 5 boxes, it makes it look like Lambda and EC2, they're like the same, right? It's not the same as EC2. It's not the same as an application. You can't have all of your application in your Lambda, in one Lambda function. Applications are complicated. And Lambdas should respect that little nagging thing called the single responsibility principle. In case you're not familiar with it, go read the Wikipedia article. Every method, every function, everything should do one thing, and let something else do the next thing, essentially. So my diagram, my 5-box diagram, maybe should have looked more like this, where I replace containers or instances with a bazillion Lambdas. Well, not a bazillion, but a lot of Lambdas. There were a lot of other things we learned over the last year. We learned, serverless is a lot about automation. I've seen so many blog posts about serverless is about automation in DevOps, automation in other things. We learned that serverless is about event-driven computing. Now, we kind of knew that already, but it really got drilled into us. It's about event-driven computing. Scalability is different. Again, we kind of knew this, but we really got to learn it. It's like scalability is really different. You got to think about it differently. You got to make sure you're doing that single responsibility principle with your Lambdas and let them automatically scale as jobs come in. So we can create a lot of serverless functions, create a lot of Lambdas, but how do you orchestrate them? How do you get them to work together? How do you get, okay, this thing runs, and then I want it to run that thing, and then I want it to run that thing. How do I get that to all work together? Well, there have been a lot of solutions for this, a lot of blog posts, a lot of sessions. I've seen some great sessions from last reInvent and a lot of AWS, what are they called, summits around the world, talking about an event queue or message queue or database as a traffic cop. And so I've seen plenty of examples of using Amazon Kinesis for that as that traffic cop, or using SQS as that traffic cop, or even Amazon DynamoDB as that traffic cop. Something that's, a Lambda does its thing and reports back to, say, Kinesis. And then the next Lambda looks at Kinesis and says, okay, I'm going to move forward, and hands it back to Kinesis. So it's that message bus, it's that event queue that's dealing with getting all these things to work together. And probably the best example I've ever seen has been this. So a guy named Rob Grule is the one I've mostly seen on stage at different summits from Nordstrom talking about Hello Retail. And this was an amazing example. In fact, you can go up to GitHub and go to that repo and try this out yourself, build it yourself. And the example is that your product manager is going to upload a product, and then photographers are notified, and they upload photos, and it automatically just shows up on the website. It's really, really cool how they do this. And they're really good at making really pretty diagrams. I try this. I cannot make a diagram that looks like that. I've never been able to do that. I am usually stuck with what I get from AWS in my Lambda list. I've got this list of Lambdas, and I've got to try to remember in my head, okay, the first one is related to the fourth one, and the second one is different, and that third one, I don't even know what that is. And some of these are updated 11 months ago, 4 months ago, last month. This is actually, yeah, this is not the way it looks now. Now, I mean, in my account, it looks a little bit better, but still, it's a lot of dummy stuff. So now enter AWS Step Functions. Step Functions makes that holy grail I talked about really the holy grail that I'm excited about. So in my demo last year, I did a image conversion kind of example. And in fact, it was one of the samples I had tweaked that I had found online. But I was doing so much in one Lambda function. I was downloading the image, I was converting it over to 4 different sizes and then to JPEGs, and but it was all in one Lambda function. And that was kind of a silly way of doing it. I really should have broken it out into multiple Lambdas that do one thing and one thing only, and then hand off to the other. But I didn't want to have to think about that message bus or event queue or database in the middle. And so Step Functions really solves that. They're still a little confusing when setting it up for the first time. But once you get over that hump, these things are really, really cool. Now, a step function essentially is a state machine. Now, what's a state machine? Oh, by the way, I'm looking at my sf.technoevangelist.com. It's keeping up. It's actually showing the right notes. Yes, a win. So what is a state machine? Well, a state machine, there are lots of textbooks definitions of what a state machine is. But I've worked for a lot of companies where we've had things that we've called state machines and things that we've called workflows and things that our customers call a state machine versus a workflow. We see that term. It's a lot of vendors out there. I worked for a company called Teamplate, and we had a product called Teamplate. Really creative. And it was this amazing workflow solution out of Calgary, Canada. This is a number of years ago. Got bought out by a company called OpenText. Got bought out by, and then when I was at OpenText, there were probably 8 or 9 different workflows being sold, workflows and state machines. And you look at different marketing literature, it's a workflow, it's a state machine. But essentially, just think of a state machine as kind of a workflow, but a little bit more focused on the event-driven nature. So event-driven workflow. Simple way of thinking about it. But what about simple workflow service? Amazon's got this simple workflow service. What's up with that? Do I stop using that? Well, if you read any of the articles, or a couple days ago, I was in a session with some of the PMs that were involved with Lambda and step functions. They're like, no. If you're using simple workflow service, keep using it. It's not going away. Just keep going. Do your thing. No big deal. But if you're starting new, yeah, totally go with step functions. There's some things that simple workflow service doesn't, or that step functions don't support that simple workflow service does. But they're pretty minimal. Pretty minimal, unless that's the one thing that you really care about. But it's for the most part, you're pretty good with going with step functions. So let's talk about some concepts about step functions. I already talked about a state machine. You can kind of think of when you upload a step function, when you create a step function, you're basically creating a template, and then you're instantiating that template. And those instantiations are called executions. Now, a state machine is made up of multiple states. And the states, we've got about 7 states listed there: task, choice, succeed, fail, pass, wait, and parallel. And when it goes from one task to the next task, or one task to a choice, that is called a transition. So you define your state machine with the Amazon states language. And when you do that and then upload it either through the CLI or use the web interface or however you're using it, a diagram will be generated from that. And you'll get to see what stupid mistakes you've made and then go and fix it. So that's really great. So let's talk about some of those states. First off, we've got a task. A task is basically launching a Lambda. Or it could also be triggering an activity. So what's an activity? A Lambda is easy. It's just going to trigger off a Lambda and do whatever the Lambda does. An activity is you've got some other process that's on an EC2 instance or a physical box. And then you've got a worker process that just calls back to the step function infrastructure and says, hey, you got any work for me? hey, you got any work for me? Hey, you got any work for me? And finally, it has some work because a task with an activity defined in it has triggered, and then the activity is run on there and passes the information back to the state machine. There's a bunch of other things that we can define. So we can define a type. A type is going to be task, and a resource is going to be the ARN for that Lambda or for that activity. And we've also got result path, input path, and output path. These are going to let you modify the JSON input and output from each task. Got a retry and catch in case you want to catch errors in your Lambda function or in your activity. And also you want to retry. Maybe you want to retry this Lambda. If it didn't work the first time, retry a few times. And then you've got to have either a next or an end in there. Either end equals true because it's the end, or next equals whatever the next state is going to be. So here's a super simple example. We've got a state machine that starts at the task. And so then we give a list of states, the first one being the task, and it's of type task. And we give it a resource of an ARN, and then end is true. OK, simple, one-step state machine. Let's look at a choice. Choices are great because now your state does something. It spits out some variable into the JSON output, and then it says, maybe that thing is true or false. Now you can have a choice that says, if true, go that way. If false, go that way. So you define a type equals choice, and then choices, you give it a list of the choices, and you can define a default. But the other things like next and end and comment and the path stuff is all the same as what we saw for tasks. So here's an example of that. We've got a choice. It's of type choice. Here are the choices available. And the first one is if foo equals 1, then go with the first task. If foo equals 2, go with task number 2. Really, really easy. Then we have succeed, fail. These are basically endpoints with a success and a fail. So here's an example. Is it positive? If it's positive, then end with a success. If it's negative, end with a fail. Really, really simple. Move on to a pass. Pass is great. It just kind of passes through. Just lets it just go through. This is great for when you're building out your step function initially, and you just want to scope it out, but not actually build anything, or you want to have it pass through, but you want to insert additional stuff into your JSON output from the previous one before it goes into the next one. So that's really useful. Another useful one, we got a little example of pass. My Mac slept. So in this case, we're going to run first task, and when it's done, go to a pass, and it's just going to insert, wow, this was exciting, into extra detail in the result. In the resulting JSON. We have wait. Wait is something I've been using in my step function because, building out, I've got two major builds that happen in my step functions. First off, I've got the build of Gatsby.js. It does a build, and it takes about 90 seconds to do that build. The other build I have is if I make changes to my Docker file, then I have code build a new Docker image, and push that into ECS. And that takes more like 3 minutes or 4 minutes. And I don't want to just wait. So I have it do its thing, and then I run a wait for 20 seconds, and then check, is it done? Nope, OK, go back. Is it done? Nope, OK, go back. So that's really useful for me. And so here's an example of waiting. We're waiting for a timestamp path. So timestamp path means maybe the previous state specified a timestamp in the JSON output, and maybe the timestamp path is sometime maybe in the next 10 minutes. We're going to wait for that timestamp to happen, and then move on to the next step. Great. I think this is the last one. This is parallel. If I want to have, after my one task, I want it to do 2 or 3 or 4 or 5 or a bunch of things all at the same time. And when all of those are done, all those paths are done, come back and continue with the next state. So here's a simple example of that. We've got parallel. Next is final state. So next, after the parallel is done, is going to go to final state. And we start at left brain. And so if it's you start at left brain, wait for 2 seconds, and go on to sequence, and then right brain, pass, and go on to visualize. So both the left brain and right brain are going to be processed at the same time. And when both are done, when both sequence and visualize are done, then we move on to final state. So there's a lot of, so that's like the basics of step functions. Really, there's not really a lot to it. Okay, there's a little bit more to it if you read the docs, but there's not, it's pretty easy to get started with. But when using it, you're defining your states in the Amazon states language, and you have to refer to the ARN in different lambdas, which you have to go into Lambda and set up those lambdas, and then, you got to set up your IAM roles, so let's go over here and do that, and I got to set up CloudFormation, so let's go over here and do that. There's a lot of moving parts, a lot of things I need to do, and I don't want to do it. I can't think about it. So I like to use a tool to help me, and I'm using Serverless. Serverless framework is great for that, and it's got an add-on called Serverless Step Functions, which makes it really easy to build step functions, kind of based on the name. And so I'm using Serverless framework, and it's fantastic. One of the benefits of the Serverless framework is I can define everything in one file. I can define my IAM role statements. I can define my Lambda function handlers. I can define my Lambda function triggers, my step function states, my CloudFormation for everything else that Serverless framework doesn't support yet. I can just throw in a CloudFormation template inside my serverless.yaml file. So let me talk a little bit about my demo. Here are the products or the things that I'm using. Now, OK, when somebody does a demo, I think the golden rule is keep it simple. So I try to keep it simple. I try to think, OK, how can I do this in the simplest way possible with the minimum number of products? And I ended up with this list. It's a little bit more complicated than I expected. But we've got code commit. Code commit is my repository. It's basically a Git repo. I've got S3. You all know what S3 is. I got step functions because this is a step functions talk. I've got Lambda because it's also a Lambda talk. I've got CloudFormation because there were some things that Serverless doesn't support. IAM because I'm dealing with roles. ECR, ECS repository because I need to create an image that is going to build my Gatsby website. I'm using Gatsby.js because it's awesome. I'm using DynamoDB because it's storing all my notes for my slides, which you're reading on sf.technoevangelist.com. It's also got kind of a bookmark of here I am. I'm at this slide right now in case, if I see the same slide over and over and over again, hopefully it's not publishing the same picture over and over and over again. I spent a little time on that. But I've also got CloudFront and API Gateway and Code Build. Code Build is amazing. This amazing tool for building out, using those Docker images to build out my Gatsby site. Basically, it's a way of running ECS by the minute before we had Fargate a couple days ago. And we've got SNS. So a lot of neat things being used here. So again, try to keep it simple. Yeah, totally. So let's take a look at my serverless.yaml file. So in my serverless.yaml file, there's a bunch of things here. First off, I give it a name. I give it a nice name because I've inserted this way, Matt W. reInvent 2017, so people know whose it is, and it's for reInvent 2017, so I know what it is because I'm going to forget in a few weeks. And it's building a website. And I'm using a few plugins. I'm using pseudo parameters. Pseudo parameters is great for being able to use basically kind of like CloudFormation variables inside my entire serverless YAML file. Serverless step functions because it's a step functions talk. And then serverless Webpack because I wanted to use the new cool hotness in JavaScript. Because as you know, Lambda supports Node.js 6.10. Oh yeah. And I want to use async await. I want to use other things that I can't use yet. So I'm using Webpack and Babel to compile that down to something that Node.js 6.10 will work with. And then I'm also giving a custom value of reInvent 2017 website that I'm going to use elsewhere in my serverless YAML file. So continued, you have to give it a provider. Now, the provider here is AWS because, hey, we're at an AWS event. But there are other providers that you could put in there, potentially. There's a runtime of Node.js 6.10 and a stage and region. And then I give it some IAM role statements. These are not all the role statements that are in there, just a few that fit on the slide. I need to make sure that my Lambda can start. So when I run SLS deploy, it's going to create a role that's going to do everything. And now I have to give it that role access. And so the first one is I'm giving that role access to start my state machine. And I give it my actual state machine back. So that resource, that's actually one of the magic little variables that are given to you with the serverless-step-functions plugin. I don't get how it works, but it does. And then I want to allow it access to my code commit repo. So I give it access to the code commit. And those pound sign AWS : account ID, those are the serverless pseudo parameters that I use. And then I go in and define functions. So these are not all the functions. Sweet, it's still working. Awesome. These aren't all the functions, but there's some of them. So build site is one of my functions, and the handler is handler.build. What changed? Handler.whatChanged, and so forth. But my step function actually gets initiated by another Lambda called start step function. Really creative names. And that has an event of an SNS. So it's waiting for that SNS message to show up, and when it does, it's going to trigger my state machine. And then I define my step function. So there's a bunch of hierarchies at the top that are there for some reason. But then I define the name of my state machine. I called it my state machine because that's a lovely name for a state machine. And then it's going to start at what changed. So what changed is a type of task, and I have to give it a resource. And so I give it the resource, again, all those pseudo parameters in there. And then after this one, it's going to move on to build Docker or not. And so at this point, I'm going to switch over to a little bit of a demo. And I'm going to press the right button, number 3. Oh, that worked. Sweet. OK, and so we've got my sf.technoevangelist.com site over here. I've got a little plugin or extension that's updating the site every 30 seconds or so I don't have to press refresh. And over here on the right side, really, really small. Sorry, let's fix that. Oh, really, really big. OK. It is 3:03 p.m. Just to prove that it is 3:03 p.m. And it is, now, paste that in. And let's get rid of that line. And that's all good to go. Let's, as an amazing commit message. OK, cool. All your commit messages are that useful, right? OK, and then go over to my website and git push. And hopefully this is all going to work. Yes! Ethernet is awesome. Because I have an Ethernet cable and you don't. Sorry. OK, so that's up. And hopefully pretty soon we're going to see all this. Oh, reload. OK, reload. OK, cool. Here's my state machines. And I want to go to not live blogger, but to reload. To my state machine. So I've got a state machine that's running. Here's the one that's running right now. Basically, there's a few things. I've already shown you in a little bit bigger. But it skipped over a section of build Docker because I don't need it to build a Docker container because all I did was update a single web page. And then I have it build the site. And so build site is just going to build the Gatsby.js website. Let's zoom in a bit there. So how do I move around here? There we go. So now it's on build site. It's actually on wait for build. So it's waiting for like 20 seconds and then going to, is it built yet? And if it is, or if it's not, then cycle back. Is it built yet? Why did I choose 20 seconds when it's going to take a minute and a half? Well, if I chose a minute and a half and it takes a minute and a half and 1 second, now I've got to wait for 3 minutes. So wait for 20 seconds, makes sense. Oh, looks like it's done. And so I should be able to go to sf.technoevangelist.com, refresh the page. Oh, denied. OK, well, what I would have seen there, oh, OK, it's 3:00, look at that, let's zoom in. It's 3:03 p.m. and I'm doing a live demo. Whoa! Sweet. OK, cool. So we saw a little bit about actually doing one. Oh, I got to move back over to HDMI 1, I hope. Yes. So what did I just do there? I committed to code commit, and that triggered off SNS, which I had a Lambda waiting for, and that Lambda then ran. So my definition in my serverless YAML file for start step function, I said there's a handler. It's handler.start step function. It's waiting for an SNS message, and I've given an environment variable. So the actual start step function I didn't want to give you all the code because there's a lot of stuff in there, so I give you like pseudocode. It's basically just getting the step function ARN from serverless. It's getting the SNS details, and it's starting a step function execution. Pretty easy. And that step function is going to be this one. Basically, that step function is saying, what changed in the repo? So it does a diff. If it's Docker related, so it's a Docker file or my build spec.yaml or a few other files, then tell code build to build that Docker image. So it builds a Docker image and waits for it. And then checks if it's done, waits for it, checks if it's done, wait for it. Finally, it's done, and then it pushes that to the ECS repo. When that's done, then it can go ahead and build the Docker, build the website using that new Docker image or the old Docker image if it didn't have to update one, and then wait for it, wait for it, wait for it, and then send Matt an SMS. Now, I guess I've turned off my ringer because I am getting 1,000 SMS messages as we go through this. So thankfully, I turned that off. But my wrist keeps buzzing because every 30 seconds, I'm getting a notice saying, I built it. I built it. I built it. So maybe that wasn't the best decision for a demo. OK, so it's sending Matt an SMS. Great. So let's take a look at, so this is kind of the interface that you use when working with step functions and where you're doing some debugging. You'll go in here. You can click on info to see some information about that particular task or that particular state. If there's any exceptions, you'll see that in the exception tab. Input shows you what's going in, what the JSON is that's going into that task. And output is going to show you the output. So the input is the SNS message ID, a commit ID, and for some reason I threw branch in there because I thought it might be useful, and I ended up not using it. In my serverless YAML, my what changed function or task, I have a resource, and next is going to be build Docker or not. Figure out if I need to build Docker or not. And I also have throw in a few retries because I was having some sort of weird issue, and so I just have it retry a few times, about 4 times, waiting every 3 seconds. And usually the second time around, it just works. So the pseudocode for what changed, it says get the commit of the triggered step function, get the previous commit, what's different between those two, and if it was Docker related, then set has Docker to true, otherwise set has Docker to false. Again, do one thing, and that's it in your Lambdas. So that's my one thing it's doing, it's what changed. And so that hands it off to the next state, and so it's just set has Docker is true, and so now it's going to go to build Docker or not. It's a choice. The choices available are if has Docker is true, go to build Docker. If has Docker is false, go to build site. Pretty simple stuff. So build Docker is a task. It's a Lambda function. And it's going to, after this is done, it's going to go on to wait for Docker build. So build Docker, all it does is start the code build to build my Docker image. Really, really simple. Now, as I'm building this the first time, I see that it kind of works, but it fails because I didn't have the right IAM role permission. So I go back into the serverless YAML file, add one more permission. Oh, that didn't work, add one more permission. So this is how my kind of workflow going through this was, I had an idea, I put it in a bunch of passes to kind of build out the flow, replace them with Lambdas, and as I needed more permissions, go into IAM roles to add those permissions. So it triggers off a code build. Now, code build, the way code build works is you have to give it a Docker image. Now, that Docker image can live on Docker Hub. It can live on ECS. It can live on your own repos that you've got, Docker repos or Docker Hubs that you've got. So you push that in, and it builds that or creates that Docker machine, and then you pass it a build-spec.yaml. And the build-spec.yaml file is just this list of things you want it to do. And so for my build-spec YAML, I do a bunch of Docker stuff at the beginning. I log into Amazon ECR, and then build my Docker image, do my tagging. When you build a Docker image and you're going to post it up to ECS, it tells you exactly what things you need to do to tag it, and then push my Docker image up to ECS. Great. So then I go to wait for Docker build. It's just a type of wait. I'm going to wait for 20 seconds, and next thing is the container built or not? Or is the container built? So is the container built? It's a type of task, it's a Lambda, and it's going to move on to container built or not. And all at their input, I give it a container build ID so that I can know where to go to find out, is this build done yet? And is the container built just says, get the build info from code build and check if it's done. Really, really simple. And if it's done, then spit out done. Done equals true. So the output, container build done, is true. Now I can move on to the choice. Container built or not. Container build done is true, then move on to build site. Container build done false, move back to wait for Docker build. Really, really, all these things are really simple because you do one thing. You do one thing over and over again. My build spec YAML for my Gatsby site, a little bit different because I don't need to build a Docker image. I'm just doing an AWS S3 sync from my kind of raw site pages. That's where, so I'm generating these markdown files based on those images that are created by that Raspberry Pi and sticking them in raw site pages. I'm just synchronizing that back over to source posts and then build my Gatsby site and then do a sync back to the bucket that is actually my website. So here's kind of a view of that same workflow that my Raspberry Pi is doing. That picture is my Raspberry Pi in my hotel room, which, okay, it looks like kind of like a person, but it's a Raspberry Pi. And again, one of the magic things in there is that going to Vise.ai, really, really super useful service. Again, I uploaded about 6,000 images with different rotations because I wasn't sure what this room was going to look like. And then it takes like 5 hours to process it. And then after that, every time I submit a new image, it just takes like 100 milliseconds to return back with, OK, it's slide 3. And there's a 99% chance it's slide 3. Or there's a 2% chance it's slide 15, in which case it's not slide 15 because it doesn't know what it is. Now, it's not perfect. If you've looked at the site, you'll see that sometimes it has no idea what page I'm on, in which case the title is just live blog update. Ideally, I would have done this 2 or 3 days after the announcement of wasn't there like a recognition OCR service just a day or two ago? I would have updated my demo, because I live on the wild side, I would have updated my demo to also include some OCR data to verify. If it doesn't know which one it is, maybe I can do a secondary verify with that recognition service. And then it moves on to Dynamo to grab my notes and moves on to code build. OK, so I've talked about step functions. And oh, by the way, I work for this company called Datadog. And Datadog, we do monitoring. So I thought, let me just throw in a couple of slides about how do we do monitoring of all this stuff. Well, we do monitoring in 2 ways. First off, there's the CloudWatch metrics. From CloudWatch metrics, we're collecting a lot of data about Lambda, the Lambda execution times and how many failures there were, how many other things. There's like 7 or so metrics that we're collecting there. And we're collecting similar functions or similar metrics from step functions. But then we can also do custom metrics. So with custom metrics, basically where in your Lambda function, you're writing a line to the log file. If you're using Node.js, it's going to be console.log. If you're using Python, it's going to be print, I think. It's some monitoring string. And that monitoring string just looks like monitoring, all in caps, followed by a pipe character, followed by time since the Unix epoch, a value, whether it's a count or a few other options there. Give it a metric name, any name you like, and some tags. Because at Datadog, we rely on tags for a lot of the way that you create dashboards and such. So spit out that monitoring line. And so what are the Lambda metrics? Here are the metrics that we grab from CloudWatch. Lambda duration, min, max, sum, errors, invocations, throttles, and iterator age. And then here are the step function metrics. There's a bunch more. So we'll collect all those. And of course, we're collecting this data, I forget, every 15 seconds or so. And we're keeping that data at, you could also send data to us through the API. And we're going to keep it at that granularity for 15 months. So we're going to keep that data for a long time so that you can figure out, are you doing better today than you were 15 months ago or 12 months ago? So hopefully you're making a steady progress up and making things better and better. So that's a little bit about monitoring. And the next slide is my summary, because we're at the end of this session. Now, I've got a QR code for those, the cool kids in the audience. And that QR code is going to the same URL as this repo. It's a repo on GitHub. And it's the source code for the 2 serverless step functions, as well as some little utilities I needed to basically reset Dynamo back to 0 because I'm starting my session again, or pushing some bogus images and real images up there so I don't always have to have a Raspberry Pi running, and a bunch of other little things that were useful for me. It is a demo. There's no we're not responsible if you do something bad, but there's the next thing I need to do as soon as this session is done, I'm going to write some documentation so that you know what any of that does. So I need to do that still. But in summary, step functions make AWS Lambda orchestration really, really easy. Hopefully you can see that Lambda was the new hotness last year. I think step functions should be the new hotness this year. It is super cool. I am really excited about it. I am really excited about potentially having one less excuse not to update my blog more than every 15 months. Next thing, Lambda and step functions can be a super interesting part of your infrastructure. And you should definitely monitor your Lambda functions and everything else in your infrastructure, whether you're using Datadog or somebody else. You should totally monitor to ensure peak performance as you move forward. Thank you so much. My name, again, is Matt Williams. I can be reached on Twitter at TechnoEvangelist, and I work at Datadog. Come visit us in the Datadog booth. Thanks a lot.